Welcome, everybody. So today we are going to talk a little bit about motion diagrams, which is our first physics topic for the term. And we're going to do that by launching right in and analyzing a video of my dog, Dr. Paws, that I am going to share with you right here. So you should be able to see the video, and I think I've got this optimized to play nicely. We'll just go ahead and watch it once and see what happens. There she is, going after the ball. And you can watch this video on your own if you want to. We're going to go ahead and restart it. And what we're going to do is we're going to try to draw what's called a motion diagram for Dr. Paws. So we're going to try to analyze how she is moving by making a picture, a graphical representation of what is going on. And to do that, I am going to do some abstracting. I'm not a very good artist, and it is hard for me to sketch my dog. So I'm going to represent the dog as a circle. And I'm going to pick blue as my circle. So I will go ahead and represent my dog with this blue circle right there. And this is showing the position of my dog. And then what I'm going to do is I'm going to let the video keep going for a second. And I'm going to freeze it again. And now my dog's at a different position. And again, I'm going to try to identify where that position is. So I'm going to draw us another. I don't like that one. Let me try again. There we go. Now I've got another position. And in a perfect world, those dots would be the same size. But again, I am not a particularly good artist. So we're going to live with it. And we'll try another one here. All right. Let's sketch our little position here. Let's do about, I don't know, 5 or 6 of these. I think that is enough instances of the dog here. So what you can see is we have kind of traced out the path that the dog is following. And the little circles here capture the location, the position of Dr. Paws at various instants in time. Now, if I did this very carefully, and I didn't, I would want to have the different snapshots separated by equal instants in time or equal intervals in time. So I might decide to go in here and label and say this is maybe at 1 second in the video, and this is 2 seconds, and this is 3, 4, 5, 6, and 7. Now I probably didn't do a good job of that, but I probably got pretty close. Now I will say that these instants don't have to be a second apart. In fact, I'm almost certain that these are not 1 second apart. It could be that they're all half a second apart, or a tenth of a second apart, as long as they are the same amount of time apart. So you wouldn't want to have one at 1 second, and then the next one at 3 seconds, and then the next one at 8 seconds, and then at 53 seconds. They should be equally spaced in time, because then you can get a really good sense for what is happening with the motion of the dog. One thing you'll note about this particular example is that Dr. Paws is actually moving in 2 or even 3 dimensions, and I'm limited in how well I can capture depth in this particular perspective. So what I'm really showing here is the horizontal and possibly the vertical position of the dog. I could draw a 3D representation if you wanted to, but we will not usually need 3 dimensions in this course. So we're mostly going to stick to 2 dimensions until we get to Physics 212. So I've got my motion diagram. You'll notice again that I've labeled the points kind of in sequence, in order. So I know which point is the first one in time and which point is the last one in time. There are some other things that I can add to this diagram that we are going to discover in the next video.